Look at the moon tonight, that quiet, glowing sphere hanging in the sky. It controls our tides, it stabilizes our planet, it has inspired poetry, prayer, science, and space missions. But here's a question that sounds almost unbelievable. What if the moon was once part of Earth? Not just close to Earth, not just captured by gravity, but literally born from Earth's own body. Today, we're diving deep into one of the most fascinating cosmic origin stories ever proposed. The idea that the moon was created from a catastrophic collision that nearly destroyed our planet. Understand this story, we need to go back 4.5 billion years. The solar system was not calm. It was chaos. Planets were still forming. Massive rocks were colliding constantly. The early Earth wasn't the blue planet we know today. It was molten, unstable, and bombarded by debris. In this violent environment, something extraordinary happened. A Mars-sized object, which scientists call Theia, may have collided with the early Earth. This is known as the giant impact hypothesis, first seriously developed in the 1970s. According to this theory, Theia smashed into Earth at an angle. The collision didn't completely destroy Earth, but it was catastrophic enough to eject enormous amounts of molten rock into space. That debris didn't escape into the void. Instead, it formed a ring around Earth, and over time, that ring clumped together, cooled, and became the moon. Now you might ask, this sounds dramatic, but where's the proof? The evidence is surprisingly strong. Let's start with the moon's composition. When astronauts from the Apollo program brought moon rocks back to Earth, scientists analyzed them carefully. They discovered something shocking. The moon's rocks are almost chemically identical to Earth's mantle. Not just similar, almost identical in oxygen isotope composition. If the moon formed somewhere else and was captured by Earth's gravity, its chemical fingerprint should be different. But it's not. It looks like it came from Earth itself. There's more. The moon has a very small iron core compared to Earth. If it formed independently, we'd expect a larger metallic core. But if it formed from Earth's outer layers, which are rich in silicate rock and poor in iron, this makes perfect sense. And there's another clue, angular momentum. The Earth-Moon system has a strange rotational balance that fits perfectly with a massive glancing collision. All of this evidence points to one dramatic conclusion. The moon was likely born from Earth's own material. Now imagine the scene. The early Earth, molten oceans of magma, a glowing red surface. Then Theia approaches, a planetary body about the size of Mars. It doesn't hit head-on, it strikes at an angle. The impact releases energy equivalent to billions of nuclear bombs. Earth's outer layers vaporize. A cloud of superheated rock explodes into orbit. For a short time, Earth might have looked like Saturn, surrounded by a ring of glowing debris. Within weeks or months, gravity pulls this debris together. Clumps form, they merge, and within a few thousand years, a newborn moon orbits Earth. At that time, the moon was much closer. It would have appeared enormous in the sky, maybe 10 to 20 times larger than today. And it would have caused massive tides, reshaping Earth's oceans and crust. This isn't just an origin story. The moon may be the reason life on Earth was able to survive and evolve. The moon stabilizes Earth's axial tilt. Without it, our planet's tilt could vary chaotically, leading to extreme climate swings. Seasons might have become wildly unstable. Life might have struggled to adapt. The moon also drives ocean tides. Early tidal pools may have played a crucial role in chemical evolution, helping simple molecules combine into more complex ones. In other words, without that catastrophic collision, you might not be here watching this video. Scientists once proposed other ideas. The capture theory. The moon formed elsewhere and was captured by Earth's gravity. The fission theory. The moon spun off from a rapidly rotating early Earth. Co-formation theory. Earth and moon formed together from the same material, but each of these had major problems. Only the giant impact hypothesis explains the chemical similarity, the small lunar core, the angular momentum, the current Earth-Moon dynamics. Today, most planetary scientists consider it the leading explanation. though recent simulations suggest the collision might have been even more complex, possibly involving multiple impacts or rapid formation within hours instead of years. Science continues to refine the details, but the core idea remains powerful. Here's a final twist. The moon is not staying with us forever. Using laser reflectors placed during the Apollo 11 mission, scientists discovered that the moon is slowly drifting away from Earth, about 3.8 centimeters per year. Very slow, but over billions of years that adds up. Long ago, it was much closer. In the far future, it will be farther. The Earth-Moon relationship is evolving, just like everything else in the universe. So was the moon once part of Earth? All the evidence suggests, yes. Our moon may be the scar of an ancient cosmic catastrophe, a reminder that destruction can create beauty, that chaos can lead to stability, and that sometimes the things that shape our destiny come from violent beginnings. Tonight, when you look at the moon, remember, you might be looking at a piece of Earth that was torn away billions of years ago. And without that collision, the story of life on this planet might have been completely different. If you enjoyed this deep dive into cosmic history, subscribe for more mind-expanding space stories. Because the universe isn't just out there, it's part of us. And sometimes we are literally part of it.